Alright, and welcome back. Again, I'd like to apologize to hour one for having to work pretty hard to get these notes down. Hopefully you either stopped by my room and got the notes, or you downloaded them right off the website. Either way, I apologize to you guys. They end up having to replace my airliner, so I have a brand new writing utensil for my computer. So it must have been serious. Okay. So let's get some of this done here. More multiplication with properties. Okay, so the big idea, what is happening here? And we're going to go through and we're going to write this in expanded form. But if I have 4 to the 3, okay, 4 to the third power, so 4 times 4 times 4, and I do that 2 times, then that's doing 4 to the third power twice, right? That's what squaring means, is you do it twice. So 4 to the third twice. This brings us back to what we learned yesterday. This is just 4 to the sixth. I'm multiplying 3 4s here, multiplying 3 4s here. How many total 4s am I multiplying? 6. Alright? Same thing here. I'm doing 3 to the 6th power, but I am doing that 7 times. So 3 to the 6th times 7. Okay, 3 to the 6th, 3 to the 6th, 3 to the 6th, 3 to the 6th, 3 to the 6th. It gives me 3 to the 42nd power. Okay? So, when we see this, what is called powers of powers, alright, taking a power above a power, you use multiplication on the powers themselves. But more importantly, we just need to understand what we're doing, and we're going to work on that today. The other big idea, if you have two numbers, or a number and a variable, as such the case in here, and you're taking it to an exponent, then that's the same as 3x to the third times 3x to the third times 3x to the third times 3x to the third. So what it looks like is 3 to the fourth and x to the third to the fourth. 3 to the fourth is 81, x to the third to the fourth. Well, we just learned when we have something like this, we just learned we multiply, so that's x to the 12th. Let's do a couple examples. Okay, let's work through this kind of slow. So, what do I have here? I have a to the 6th to the third, which means I have a to the 6th times a to the 6th times a to the 6th. Right? A to the 6th, a to the 6th, a to the 6th is a to the 18th. Alright? And again, the shortcut method would be take 6 times 3. But make sure you understand what you're doing here. B to the 8th to the 1/4. Okay, well, b to the 8th times 1/4 just equals b squared. 8 times 1/4, what's 1/4 of 8? It's 2. Alright, here's another one. We got some negative exponents that I've put in there for you. That's nothing more than 1 over t squared. And over here, squared. Once I flip it, that becomes positive. This one becomes 1 over t squared. And again, once I flip that, my 5 becomes positive, equals 1 over t squared. How many times are we multiplying these together? To the 7th power. Okay. A little more simplifying to do. I got a 2 in here. This, again, hopefully you recognize as powers of powers. What we started with right here, what we have right here. So this just finalizes as 1 over t to the 14th. Okay? Alright. Number 4. Number 4. Remember, this is the same as saying 3 to the negative 4 n to the negative 24. Powers of powers. We know that every number that doesn't have an exponent has a 1. 1 times negative 4 is there. So 1 over 3 to the 4th and 1 over n to the 24th. Okay? Again, now I'm making them a little bit more messy, but it's the same thing. 2 to the third x to the 1/6 times 3, and you have an x squared out here. Okay? We see this powers of powers, and we know we're multiplying. So this is 2 to the third, which is 8. This is x. 1/6 of 3 is 1/2. So x to the 1/2. Talked about what that means. Times x squared. Alright? We're multiplying like bases. This is not powers of powers. This is something different. I have 1/2 x that I'm multiplying together here. I have 2 x's that I'm multiplying together here. So how many total x's am I multiplying together? And we always want it in fraction form. So we're going to have to write this out to the side. 1/2 plus 2. Remember, we need a common denominator. So I'm going to multiply this by 2 on both sides and end up with, whoops. Whoa. End up with 4 over 2. So 5/2 is what we end up with. Okay? Last one. This one's pretty simple. I have powers of powers here, but if it's a -1, why don't we just go ahead and flip it? Okay, I'm not going to find a -4 and then I get a -1 and have to flip all this stuff in here. I'm just going to flip the whole thing. So mg to the 4th. Then the whole thing's to the 1, but we don't have to write that. Times mg to the 4th. Well, these are the same thing on opposite sides, so we cancel. My answer, 1. Alright. Now, let's talk about this. We've been struggling with some of these scientific notation aspects, so let's talk about how we do this, okay? We got scientific notation, and we are wanting to distribute the 2, or take powers of powers. This is nothing. This is multiplication right here. Nothing changes, so it's 3 squared times 10 to the 5 times 2. So 3 squared is 9 times 10 to the 10th power. Okay? Same thing. Nothing changes. Alright? This is between 1 and 10. Remember, we always want this between 1 and 10, so we're good. We're done. Okay? Over here, got the same thing. So 2. Let's try that again. Not used to my icons yet. You'll just have to give me just a second here. Set up my eraser. Okay? So 2.37 to the 3rd power times 10 to the negative 12. Alright. Let's take our calculator out and take 2.37 to the 3rd power. And you should get 13.31. There's some other stuff, but I'm going to round it off right there. Times 10 to the negative 12. Remember, I want this between 1 and 10. Less than 10, it can be 1, but less than 10. So I have to make it 1.331. I made this number smaller, which means I have to make this bigger. So times 10 to the negative 11th power. Alright. Alright. Well, I will, oh wait, one more. Complete the equation, number 9 and 10. Okay? What is number 9? What is number 10? Go ahead and fill those in. How do we make those what they are? We have powers of powers here, so hopefully you're thinking multiplication. So what, whoops, so what times 3 equals 15? 5. 5. So this should be a 5 right in here. And over here, same kind of thing. 7 times what equals 5. Well, if we divide by 7 over here, divide by 7 over here, you find out that it should be 5/7. Okay? Alright, any questions? Let me know. We got some big work to do on Friday. Hope you come prepared. See ya Friday.